text files do you have? Which text files are you drawing from at any given time? And then what is the probability that certain content will appear or not appear? Okay, so right now, what we have done, it's an equally distributed probability. And what I mean by that is for example, in this fall verbs text file, I have 40 verbs, and I'm using a random object that randomly selects between 0 and 39, and then adding 1 to get 1 and 40. So my probability of getting any of these verbs at any given time is all the same, right? I'm not going to get acknowledge more than I get return. I'm not going to get push more than I get jump. The chances that all of these appear are all totally equal. And for our purposes thus far, that has been totally fine. But you might find yourself in a situation where actually not all words are created equal, and you want to be able to get more of some words more often, and then less of other words. And so we need something then to replace our random object, something that still will have some sort of randomness, some sort of stochasticity to it, but will allow us to say, hey, actually, I would rather have line 40 way more often than I want to have line 1. And so, how do we do this? You know what? I think for the sake of demonstration, let's do something that's a little bit smaller rather than 40 options of verbs. Let's go look at our punctuation here at the very end. So here's our text file for our punctuation. I chose question mark, exclamation, period, double exclamation, smile, and frown. So there's 6 options. And maybe I want my poetry robot, let's say, very indecisive, very questioning. So I want to get a lot more question marks than anything else. So how am I going to do that? So the question mark is the first line. So I want to get way more ones out of this, whatever random object I choose to use, than any of the others. And there is an object in Max called itable. I-T-A-B-L-E, itable. And itable is actually like a visual interface of an XY grid. So an x-axis along the horizontal axis, and then y along the vertical axis. So as I roll my cursor along the x-axis, you can see up at the top the x value is changing. It's growing from the left to the right, from 0. Right now the default is 127. And then the same thing for y. If I start at the bottom, y is 0, and I can go up. Again, the default is 127. This visual interface is useful for a lot of things, and in fact, this allows you, if you were going to use it in a different way, not in a stochastic random way, you can actually use this as interpolation for x and y. So I could say, I could draw a graph here, and then I could send an x value into the itable, and I could get out its corresponding y value. So for example, x34, at 34, the y position is currently 53. That's where I just drew it in. So if I type in 34, oops, oh no. If I type in 35, no? What happened? Why am I getting 92? Outputs, indices. There we go. Oh, sorry. That's because the number I was looking at was where my mouse currently is, not the interpolated value. Silly. Okay. So if I put my mouse at, let's do my example again. If I put my mouse x34, this looks like it's y right around 90, 92, there we go. Then I should, if I type in 34, I should get something close to 92, 34. Oh, we've lost it. It still worked. Okay. And I could walk across the x value and kind of I get more output from here. We are going to use itable in a different way, because what we wanted, remember, is to get some values of 1 through 6, 1 way more often than 6, 5, 4, 3, or 2. So click on your itable and go to the inspector. And by default, our ranges was 0 to 127. And what you want to look for down at the bottom is the table range and the table size. Now, I personally can never remember if range is x and size is y, or if range is y and size is x. So I always just have to type it in and find out. So let's see, table range, let's try 6. Okay. So that was my y value. So let's change, we want our size to be 6. And then let's change, I think, if I'm reading this right, we want our range to be something else. Yes. Okay, so we want the x value to be 1, 2, 3, 4, 5, or 6. So did we accomplish that? Yes. 1, 2, 3, 4, 5, 6. And then your y value can frankly be anything you want. Let's put it at 100, because we often think of probabilities in this normalized percentage range, right? The probability that something happens is 50%. So you're going to change your table range to 100 and your table size to 6. And now what you can do is individually choose the probability that each of these things is chosen. So for 1, I'm going to put my value quite high, maybe, I don't know, 68. And then the others I'm going to put lower, for right now. It doesn't really matter what you put here. And then, instead of an integer for an x value, I'm going to use a bang. So same as the random object, I can send a bang into itable. And if I've done it correctly, I should get one of these values, either this guy, this guy, this guy, this guy, or this guy. And it should skew towards this first column, which is actually currently 0, x equals 0, way more often. So just click through this bang a couple of times, and you should notice that you're returning to 0 quite often. And that is just because I put my probability value very high for my 0. If I put it even higher, so maybe all the way to the top, and I put these ones even lower, so maybe 10%, right? I get a lot of zeros, and then very, very few of the others as I click through this. Okay, so now all I have to do is just replace, I'm gonna make it smaller so it fits, just replace this setup here replace my random with this setup. We do need to keep our +1 here because same as the random object, the itable object starts at 0, and we are wanting to start at 1. And now I should zoom out here, clear this. Lots of question marks, not a whole lot of anything else. Okay, so here's our probability, right, that we've set up. We have now made our poor little poetry robot very indecisive, and instead of having so many smiley faces, we just have a lot of question marks.